On today's lesson, we did a bell ringer that was a warm-up where you have to factor into primes. I need you to do these problems so that you remember how to do the prime factoring tree. I'll show you a couple of examples. With 26, since it's even, it ends in a 2, you can divide by 2. 2 and 13, 2 is prime, 13's prime. That's the only factoring for 26, 2 times 13. Now with 70, I'm going to go 7 times 10, 7's prime, 10 isn't, so you can factor further. 2 times 5, both of those are prime. That's as far as you go with 70. Now keep going with the other 4 problems, and then turn this back on and see if you got them factored correctly. So press pause. Okay, as you come back and take a look at the answers, we get 26 was 2 times 13, 70 was 2 times 5 times 7, 27 it's 3 threes multiplied, and so on. You can check your answers there. Okay, we need that skill in order to do today's lesson. What we worked on were operations with square roots. Remember that I'm going to go through this kind of quickly, but you can pause it so that you can get the notes written down. Okay, we talked about a radical being that expression written with a radical symbol. It's not just a square root symbol. It's used for more than just square roots. Radicand is the number or the expression inside the radical symbol. So you'd see something like the square root of 25. The 25 is the radicand. So what does it mean to find the square root of a number? Square root of 25 is 5 because 5 times 5 gives you the radicand number 25. We're looking for 2 identical factors that multiply to be the radicand. Okay, what we did on the calculator was we just did some square roots. Square root of 48. We grabbed our calculator, and when you do that, square root of 48 to the nearest tenth would be 6.9. Square root of 110 should be 10.5. I'm saying approximately with my symbol because these are all rounded. They're not exactly. Square root of 70, 8.4. So using the calculator in order to get decimals. Then we made a list of perfect squares. We went like square root of 0, 0, square root of 1 is 1, square root of the next one would be 4, 9, 16, and so on. You can make a list probably up to 15 as your answers. Then we calculated with the Pythagorean theorem. So 5 squared plus 10 squared equals c squared. We've done this before, so just a reminder. 25 plus 100. So to get c, you have to do the square root of 125. The directions here say nearest tenth. So that is 11.2, is approximately the hypotenuse. A problem with the square root of 3 as a side. It's still a right triangle, Pythagorean theorem. And when you do the square root of 3 squared, that should come out just plain 3. Because you're squaring and then square rooting, those are like opposite operations. They will undo each other. So on this one, C was the square root of 39. That's 6.2. The hypotenuse is the longest side of the right triangle. Okay, then we started just simplifying radicals. So again, pause so that you can write your notes down. When we simplify radicals, we're looking for duplicate factors and we will factor them out. So the square root of 12, do your factoring tree. List the factors. If you'll put them in order, it will be easier to do the next step. Make sure you're just using the prime numbers in your factoring. Now what we do is look for duplicate factors. You see there's a 2 there twice, so that factor comes out of the square root. Why does it come out? Well, it's like taking the square root of 4. The square root of 4 is 2, so we could do that simplifying. Okay, let's do the other numbers that are here. I'll pause when you need to. Square root of 20. Do your factoring tree. From the factoring tree, you should have 2 times 2 times 5. There's a pair of 2's, so that comes out, and we get 2 times the square root of 5. How do we know that's more simple? The number, the radicand, does not have any perfect square or duplicate factors in it. Square root of 50. Do your factoring tree and then start this up again. You should have 2 times 5 times 5. So this time there's a pair of 5's. And the 2 does not have a pair to go with it. Square root of 300. This one's going to have more factors once you get your tree done. So pause and do your tree. Okay, the factors should have been 2 times 2 times 3 times 5 times 5. This one has a pair of 2's, that comes out, a pair of 5's, that comes out, and a square root of 3. So multiply the 2 and the 5 together. So we get 10 times the square root of 3. I'll go through some more examples. I'll go fairly quickly, but you should, again, pause this so that you can catch up and get the notes finished. And test yourself, see if you can do what's being done here. Okay, so pause it and then start up later. There's a pair of 2's, there's a pair of 3's, and there's an extra 2. Square root of 75. Factor. So that one had a pair of 5's. 112. Okay, so there's a pair of 2's, there's a second pair of 2's, and there's an extra 7. And 54, factor. Let's see, I should start with the 2. There's a pair of 3's. There's an extra 2 and 3. So we get 3 times the square root of 6. Now when the directions say to simplify radicals, that's what it means. Don't go to decimal, it means go to your square root. And we just did a few more problems related to the Pythagorean theorem. But notice the directions say reduce radicals. So again, pause this because I'm going through it fairly quickly. Square root of 50. Get your tree. There's going to be a pair of 5s for the exact answer. Again, your tree. See the 2 5s? Whoops. Well, 5 is the hypotenuse. So we're missing a leg here. Subtract the 17 from each side. Do your tree. Should be 2 times the square root of 2. And one more problem, a distance formula. The bell might ring on me here, but I'll try and finish for you. Again, pause it so that you have time to work it. Need some factoring. There's a pair of 2s, and there's an extra 29. I want to make sure I did that factoring right for you. Yes, that looks right. All right, we didn't do these in class, but just in case there's something on the assignment, when you multiply, you really just get the square root of 18, but then simplify. So it's doing that first step, just multiplying together. So as I said, we didn't do these in class. Oh, this one's a perfect square. The next one's actually a perfect square. And that bottom one, if you factor, whoops, 3 times 10, there are no duplicates, so that one doesn't simplify. All right, that's what we did in class. Our assignment was page 539, 6 through 11, 20 to 22, and 35 to 43. All right, hopefully that helps you figure it out.